All right. So now let's try the sine one. Sine is even easier. You just have to do one integral. So Bn equals to 2 over 2 integral from 0 to 2 of 2x minus x squared sine n pi over 2x dx. Put the tabular. Then the integral of sine n pi over 2x will be negative 2 over n pi cosine n pi over 2x. And then the next one will be negative 4 over n squared pi squared sine n pi over 2x. Integrate again, it's positive 8 over n cubed pi cubed cosine n pi over 2x. So that this integral would be, you go across like that, so it's negative 2x minus x squared cosine n pi over 2x. And then you go across like that, that's plus 2 minus 2x sine n pi over 2x. And then negative, positive, so it'll be minus 16 over n cubed pi cubed cosine n pi over 2x. Okay. Again, if you plug in 2 into sine, you get 0 because you get sine n pi. Then when you plug in 0, sine 0 is 0. So the sines don't produce anything. Now this one has cosine. However, there's something about this function. I made this function so that this actually factors into 2 minus x times x. Right? You can factor an x out. Which means if you plug in 2, what do you get? 0. If you plug in 0, you get 0. So in both cases, this side will give you 0, so that that one, again, doesn't contribute anything. So the only thing that gives you a non-zero thing is from here. And when you plug in 2, that's cosine n pi. We know that cosine n pi gives you negative 1 to the nth power. And when you plug in 0, it's 1, so you subtract 1. So that's your Bn, and therefore we see that 2x minus x squared can be represented as the sum from 1 through infinity of this thing, negative 16 over n cubed, pi cubed, negative 1 to the nth power minus 1 times sine n pi over 2x. Okay? So you represented this function 2x minus x squared as sum of sine functions. What does it mean? It means that if you draw the graph of this, of course you can't draw it with infinitely many sines, so let's say you truncate at like, say, 1 million terms. Okay? You can do that easily with a computer. And then if you draw the graph, this and this will agree on the interval 0 to 2. They're going to agree. Yeah. Surprisingly, they're indistinguishable. Okay? But once you go outside 0 and 2, they're going to be different.